Hey guys, tonight we begin with something that might keep you awake wondering. A question so fundamental, it challenges everything we think we know about time itself. Could time actually reverse? Could entropy, that relentless march toward disorder, somehow turn around and walk backwards? We're diving into the sleepy world of Ludwig Boltzmann, a brilliant Austrian physicist whose late-night thoughts about probability and possibility would revolutionize our understanding of the universe itself. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. Picture this, it's Vienna, 1877. Gas lamps flicker in narrow cobblestone streets, while inside his modest study, Ludwig Boltzmann sits hunched over his desk, scribbling equations that would make most mathematicians weep. His beard is unkempt, his eyes bloodshot from another sleepless night wrestling with invisible demons. Not literal demons, mind you, but something far more terrifying to a physicist. The demons of statistical mechanics and the arrow of time. Boltzmann wasn't your typical scientist. While his colleagues debated theories over afternoon tea and polite academic discussions, Ludwig was having full-blown philosophical breakdowns about the nature of reality. He'd pace his study until dawn, muttering about probability distributions and molecular chaos, occasionally stopping to furiously scratch out another equation that brought him closer to an unsettling truth. Time, he was beginning to realize, might not be what any of us thought it was. But here's where it gets interesting. Boltzmann's sleepless nights weren't just about academic curiosity, they were about survival. You see, Ludwig was fighting a war on two fronts. On one side, he was battling the established scientific community who thought his ideas about atoms and statistical mechanics were complete nonsense. Atoms? Invisible particles? Preposterous, they said. Show us the evidence. On the other side, he was wrestling with something even more disturbing. His own equations. The beautiful mathematical structures he'd spent years constructing were telling him something that seemed impossible. They were whispering that time itself might be nothing more than an illusion, a statistical fluke, a cosmic accident that could, in theory, reverse itself at any moment. Now, before we dive into the mathematical rabbit hole that consumed Boltzmann's life, let me paint you a picture of what entropy actually looks like. Imagine you're sitting in your kitchen and you accidentally knock over a sugar bowl. The sugar crystals scatter across the floor in a chaotic, random pattern. Your immediate thought? Well, that's a mess I'll never be able to put back exactly as it was. And you'd be right. The sugar has gone from a state of order, neatly contained in the bowl, to a state of disorder, spread across your kitchen floor. This is entropy in action, the universal tendency for things to move from order to disorder, from neat to messy, from organized to chaotic. It's happening everywhere, all the time. Your coffee cooling down, your phone battery draining, your room becoming cluttered despite your best efforts, even your body aging. All of these are examples of entropy increase, and they all point in the same direction, forward through time. But here's what kept Boltzmann awake at night. His equations were telling him that this sugar bowl scenario, while incredibly unlikely, wasn't actually impossible to reverse. Mathematically speaking, there was a tiny, infinitesimally small, but non-zero probability that those sugar crystals could spontaneously reassemble themselves back into the bowl. The molecules could, purely by random chance, happen to move in exactly the right way to undo the mess. Think about that for a moment. Your spilled coffee could theoretically unspill itself. Your broken phone could spontaneously repair itself. Your wrinkled clothes could smooth themselves out. The mathematics suggested that given enough time, enough random molecular motion, these reverse processes weren't just possible, they were inevitable. This realization hit Boltzmann like a freight train. If entropy could theoretically reverse, if disorder could spontaneously become order, then what did that mean for time itself? Was the arrow of time, that fundamental directionality we all take for granted, just a statistical preference rather than a physical law? The more Ludwig thought about it, the more troubled he became. His colleagues were already skeptical of his atomic theories. If he started suggesting that time might be reversible, that the future could become the past through sheer probability, they'd think he'd completely lost his mind. But the mathematics didn't lie. The equations were elegant, beautiful, and terrifyingly consistent. Let's pause here and think about what this actually means for our everyday experience. Right now, as you're watching this video, billions upon billions of molecular interactions are happening in your body, in the air around you, in the device you're watching on. Each of these interactions follows the laws of physics, but when you zoom out and look at the big picture, they create what we call the arrow of time. Your heart beats forward through time. Your thoughts progress forward through time. The video you're watching plays forward through time. But according to Boltzmann's statistical mechanics, each individual molecular interaction could just as easily happen in reverse. There's nothing in the fundamental laws of physics that prevents it. The only thing preventing your heart from beating backwards, your thoughts from unthinking themselves, or this video from playing in reverse is probability. Mind-boggling, astronomical, almost impossible probability, but probability nonetheless. This is where Boltzmann's genius truly shines. He realized that what we call entropy isn't really about energy or heat or disorder in some abstract sense. It's about probability. It's about the number of ways that matter and energy can arrange themselves. A tidy room has fewer possible arrangements than a messy room. An ice cube has fewer possible arrangements than the same water spread out as vapor. The sugar in the bowl has fewer possible arrangements than the sugar scattered across the floor. But here's the kicker. Boltzmann showed that the universe is constantly exploring all these possible arrangements through random molecular motion. Most of the time, it's exploring the high entropy, high probability arrangements. The messy room, the scattered sugar, the lukewarm coffee. But occasionally, incredibly rarely, it might stumble into one of those low entropy, low probability arrangements. The spontaneously clean room, the self-assembling sugar, the coffee that heats itself up. And if that's true, if the universe is just randomly sampling from all possible arrangements, then time becomes something completely different from what we thought. Time becomes a measure of probability rather than a fundamental dimension. The past is just the collection of low probability arrangements we've already moved through. The future is the collection of high probability arrangements we're likely to move into next. But what about those rare moments when the universe samples a low probability arrangement? What happens when entropy temporarily decreases? Boltzmann's equations suggested something remarkable. From the perspective of someone experiencing that entropy decrease, time would appear to be running backwards. Imagine you're watching that spilled sugar spontaneously reassemble itself. From your perspective, watching this incredibly rare event unfold, you'd see the sugar crystals moving in reverse, defying everything you know about cause and effect. But here's the truly mind-bending part. If your brain, your memories, your entire nervous system were part of that same entropy reversing process, you wouldn't experience it as time running backwards. You'd experience it as time running forwards, but in the opposite direction. This is where Boltzmann's late-night musings become genuinely unsettling. If entropy can reverse, if low probability arrangements can spontaneously occur, then there might be entire regions of space-time where time flows backwards. Entire universes where cause follows effect instead of preceding it. Entire realities where people are born old and die young, where broken things spontaneously repair themselves, where knowledge becomes ignorance and questions become answers. The mathematical framework was beautiful and terrifying in equal measure. It suggested that our experience of time's arrow might be nothing more than a local phenomenon, a temporary direction in an otherwise directionless universe. Like a river that happens to be flowing downhill for now, but could just as easily flow uphill if the landscape were different. Boltzmann's contemporaries weren't ready for these ideas. The notion that atoms existed was controversial enough without adding reversible time to the mix, but Ludwig couldn't shake the implications of his own work. He'd spend entire nights pacing his study, calculating probabilities, sketching diagrams of molecular motion, trying to understand what it all meant for human consciousness and experience, because that's the real question, isn't it? If time can reverse, if entropy can decrease, if the universe can spontaneously organize itself into lower probability states, what does that mean for us? What does that mean for memory, for causation, for free will? What does that mean for the very notion of existence itself? These weren't just abstract mathematical curiosities for Boltzmann. They were existential riddles that kept him awake, that made him question everything he thought he knew about reality. And as we'll see, his sleepless nights would eventually lead to insights so profound they'd reshape our understanding of thermodynamics, statistical mechanics, and the fundamental nature of time itself. But the journey wasn't easy. The deeper Boltzmann dove into the mathematics of reversible entropy, the more isolated he became from the scientific community. His ideas were too radical, too unsettling, too far ahead of their time. The loneliness of being right about something nobody wants to believe is a special kind of torture, and Boltzmann felt every moment of it. Yet he pressed on, driven by an almost obsessive need to understand what his equations were telling him about the universe. And what they were telling him was this: the distinction between past and future, between cause and effect, between order and disorder, might be nothing more than statistical preferences rather than fundamental laws. The universe, in all its vast complexity, might be nothing more than a cosmic probability distribution, constantly sampling from all possible arrangements of matter and energy. And in that sampling process, In that endless exploration of possibility space, time itself emerges not as a dimension or a force, but as a direction, a statistical bias toward high entropy arrangements that creates the illusion of forward motion through something we call the future. But it's an illusion that can break down, can reverse, can flow backwards through the very same probability distributions that created it in the first place. This revelation haunted Boltzmann through the cold Vienna winters. Picture him again in that dimly lit study, but now the stakes have changed. He's no longer just wrestling with abstract mathematics. He's confronting the possibility that everything we experience, every memory we cherish, every plan we make, might be nothing more than fleeting patterns in an ocean of cosmic probability. The breakthrough came during one particularly brutal, sleepless night in 1878. Boltzmann was staring at his equations, coffee long since gone cold, when something clicked. The mathematics wasn't just describing entropy as a tendency toward disorder. It was revealing entropy as a measure of information itself. Every arrangement of atoms, every possible configuration of matter and energy was essentially a piece of information encoded in the structure of reality. And here's where it gets absolutely mind-bending. Information, Boltzmann realized, doesn't have a preferred direction in time. A book can be read forwards or backwards. A message can be encoded or decoded. A pattern can emerge or dissolve. The information itself is neutral, existing independently of the temporal direction we use to perceive it. This meant that the universe wasn't just randomly sampling arrangements of matter. It was randomly sampling arrangements of information. And consciousness, human awareness, our entire experience of existence, was nothing more than a particular type of information pattern, a complex, self-referential arrangement that happened to be aware of its own existence. But if consciousness is just an information pattern, and information patterns can theoretically reverse, then consciousness itself could reverse. Boltzmann began to envision scenarios where human awareness could flow backwards through time, experiencing life in reverse order, but from the perspective of that reversed consciousness, everything would still feel perfectly normal and forward-moving. Imagine living your life backwards, but experiencing it as forwards. You'd wake up each morning with the memories of tomorrow, make plans for yesterday, and feel the satisfaction them. Your birth of completing tasks before you began would be the end of your story, and your death would be the beginning. But from your perspective, inside that reversed information pattern, everything would feel completely natural and linear. The implications were staggering. If consciousness could reverse, along with entropy, then there might be versions of you, right now, living your life backwards. Versions experiencing this exact moment as part of their past rather than their future. Versions for whom your childhood is yet to come and your old age has already been lived. Boltzmann's equations suggested something even more unsettling. In an infinite universe with infinite time, every possible information pattern would eventually occur. Not just once, but infinitely many times. There would be infinite versions of you living this moment forwards, infinite versions living it backwards, and infinite versions experiencing it in every conceivable temporal direction. This is what philosophers would later call the eternal recurrence. But Boltzmann was approaching it from pure mathematical probability rather than philosophical speculation. His equations were telling him that in the vast expanse of possibility space, every possible arrangement of atoms, including the exact arrangement that constitutes your current conscious experience, was not only possible, but inevitable. Think about what you're experiencing right now. The specific pattern of neurons firing in your brain, the exact configuration of thoughts and sensations that make up this moment of consciousness. According to Boltzmann's statistical mechanics, this precise pattern will occur again, not just once, but infinitely many times, scattered throughout the vast reaches of space and time. But here's where it gets truly strange. Some of those repetitions will occur in universes where time flows forward, just like ours. Others will occur in universes where time flows backward, and still others will occur in universes where time flows in directions we can't even comprehend, following probability gradients through dimensions of possibility that our forward-flowing minds can't imagine. The loneliness of this realization was crushing. Boltzmann found himself contemplating not just the reversibility of physical processes, but the reversibility of meaning itself. If every possible arrangement of matter and consciousness would eventually occur, then nothing was truly unique. Every triumph was destined to be repeated infinitely. Every tragedy was guaranteed to unfold again and again across the cosmic probability distribution. Yet there was also something profoundly beautiful in this vision. If consciousness could reverse, if entropy could decrease, if time itself was just a statistical preference, then the universe was far stranger and more wonderful than anyone had imagined. Reality wasn't a clockwork mechanism grinding inexorably toward heat death. It was a vast space of possibilities, constantly exploring every conceivable arrangement of matter, energy, and information. Boltzmann began to see patterns within patterns. The entropy increase we observe in our daily lives wasn't a fundamental law, but a local phenomenon. Like finding yourself in a valley and concluding that all of reality slopes downward, we experience entropy increase because we happen to exist in a region of space-time where that's the dominant statistical tendency. But the mathematics suggested that elsewhere in the universe, in regions separated from us by vast distances or unimaginable spans of time, entropy might be decreasing. Time might be flowing backwards. Consciousness might be experiencing reality in reverse. The universe might be organizing itself into increasingly complex and unlikely arrangements, defying everything we think we know about the second law of thermodynamics. This wasn't just theoretical speculation. Boltzmann's equations made specific predictions about the probability of entropy reversal. They calculated exact numbers for how likely it was that a given arrangement of particles would spontaneously organize itself into a lower entropy configuration. The numbers were tiny, almost impossibly small, but they weren't zero. In a finite universe with finite time, these entropy reversals would be so rare as to be practically impossible, but in an infinite universe with infinite time, they became not just possible, but inevitable. Somewhere, somewhen, your spilled coffee would unspill itself. Your broken heart would unbreak. Your forgotten memories would unforget themselves. The mathematical framework was elegant in its simplicity and terrifying in its implications. Every moment of decrease in entropy, every spontaneous organization of matter into unlikely patterns would be experienced by conscious observers as completely normal. They wouldn't see time running backwards because their consciousness would be running backwards along with it. This led Boltzmann to a disturbing conclusion. We have no way of knowing whether we're currently experiencing time in its normal forward direction or whether we're part of an entropy reversing process that's flowing backward through the probability space of possible arrangements. The experience would be identical either way. The sleepless nights intensified as Boltzmann grappled with these implications. He began to question not just the nature of time and entropy, but the nature of scientific inquiry itself. If every possible arrangement of matter was equally probable in the long run, if consciousness could flow in any temporal direction, then what did it mean to discover truth about the universe? Was he uncovering fundamental laws of nature, or was he simply experiencing one particular information pattern among infinite possibilities? Were his equations describing objective reality, or were they just one possible way of organizing experience among countless others? The questions multiplied faster than he could answer them, each one leading to deeper levels of uncertainty about the foundations of knowledge itself. But perhaps most troubling of all was the realization that his own scientific work, his late-night calculations, his moments of insight and discovery were all part of the same probability distribution he was studying. His consciousness, his curiosity, his drive to understand the universe were all information patterns that could theoretically reverse, could flow backward through time, could experience themselves in any conceivable temporal direction. The scientist studying entropy was himself subject to entropy. The mind contemplating reversible time was itself potentially reversible. The consciousness exploring the mathematics of possibility was itself just another possibility in the vast space of arrangements that the universe was constantly sampling. Boltzmann found himself caught in a strange loop of self-reference. His equations were describing a reality that included his own process of discovering those equations. His mathematics was mapping a territory that contained the very act of mathematical mapping. His consciousness was exploring possibilities that included all possible states of his own consciousness. And in that strange loop, in that recursive reflection of mind contemplating itself, contemplating reality, Boltzmann glimpsed something that would haunt him for the rest of his life, the possibility that understanding itself might be reversible, that knowledge might be able to unknow itself, that discovery might be able to undiscover its own foundations. The implications rippled outward like waves in a pond, touching every aspect of human experience. If time could reverse, if entropy could decrease, if consciousness could flow backward through information space, then what did it mean to live a meaningful life? What did it mean to make progress, to learn, to grow, to love? These weren't just abstract philosophical questions for Boltzmann. They were existential crises that struck at the heart of what it meant to be a conscious being in a probabilistic universe. And as the long Vienna nights stretched on, as the equations grew more complex and the implications more unsettling, Ludwig Boltzmann found himself face to face with the most fundamental question of all. In a universe where everything that can happen will happen, where every arrangement of matter and consciousness is equally inevitable, where time itself might be nothing more than a statistical accident, what does it mean to exist at all? The answer to that question would drive Boltzmann deeper into mathematical territory that few had dared to explore. But first, he needed to grapple with something even more immediate and unsettling. If his equations were correct, if entropy could indeed reverse through pure probability, then the very act of making a scientific prediction became paradoxical. Picture Boltzmann in his study, now surrounded by towers of paper covered in calculations. He's realized something that makes his hands shake as he writes. Every prediction his equations made about the future could, in principle, be reversed. If he calculated that a gas would expand and cool, there existed some infinitesimally small probability that it would instead compress and heat up spontaneously. If he predicted that a hot object would cool down, the mathematics admitted the possibility that it might spontaneously grow hotter. This wasn't just academic hair-splitting. This was striking at the foundation of scientific prediction itself. How could you build a reliable science on laws that admitted their own violation, however unlikely? How could you make meaningful statements about cause and effect in a universe where effects could spontaneously become their own causes? The problem gnawed at him through the winter of 1879. Vienna was particularly cold that year, and Boltzmann found a grim irony in watching his breath fog the window while contemplating whether the heat from his fireplace might spontaneously reverse direction and flow back into the logs. Mathematically, it was possible. Practically, it would never happen in a billion lifetimes. But the distinction between mathematical possibility and practical impossibility was precisely what his work was calling into question. He began to develop what he called the fluctuation theorem, though he'd never publish it under that name. The idea was elegant and disturbing in equal measure. In any finite system, over any finite period of time, you would occasionally observe small decreases in entropy, tiny reversals in the arrow of time, brief moments where disorder spontaneously organized itself into order. These fluctuations would be rare, lasting only brief instants before the relentless tide of probability swept them back toward higher entropy states. But they would be real, measurable, observable violations of what everyone assumed was an inviolable law of nature. The second law of thermodynamics, the principle that entropy always increases, was not actually a law at all. It was a statistical tendency, powerful and reliable, but not absolute. Boltzmann realized he could calculate the exact probability of these entropy fluctuations. The mathematics was beautiful, involving exponentials and logarithms that seemed to dance across the page in elegant patterns. For any given system, he could determine precisely how likely it was to spontaneously decrease its entropy by any specified amount. The numbers were staggering. For a macroscopic system like a glass of water, the probability of a significant entropy decrease was so small that it would take longer than the age of the universe for such an event to occur. But for microscopic systems, for small collections of particles, entropy reversals would be commonplace. In fact, they would be constantly occurring, tiny violations of the second law happening billions of times per second in every drop of water, every breath of air. This realization led Boltzmann to a profound insight about the nature of irreversibility. What we call irreversible processes, the one-way flow of time, the increase of entropy, are not fundamental features of reality. They are emergent properties that arise from the statistical behavior of large numbers of particles. Individual particles have no preferred direction in time. It's only when you have enormous collections of them that statistical preferences create the appearance of temporal direction. But here's where Boltzmann's genius truly showed itself. He realized that this same principle applied to consciousness itself. Human awareness, with its billions of neurons and trillions of connections, was exactly the kind of large-scale system where statistical preferences would create the illusion of temporal direction. Our experience of time's arrow wasn't because time itself had a direction. It was because consciousness was a macroscopic phenomenon subject to the same statistical laws that governed all other complex systems. This meant that consciousness and entropy were intimately connected, not just metaphorically, but mathematically. The arrow of time we experience is the same arrow that drives entropy increase. Our sense of past and future emerges from the same statistical mechanics that makes hot coffee cool down and scattered sugar stay scattered. But if that's true, Boltzmann reasoned, then consciousness itself should be subject to entropy fluctuations. There should be moments, incredibly rare but mathematically inevitable, where consciousness briefly experiences time in reverse. Moments where memories form backwards, where thoughts unthink themselves, where awareness flows from future to past instead of past to future. These wouldn't be dramatic, movie-like scenes of time running backwards. They would be subtle fluctuations in the direction of conscious experience, so brief and rare that they would likely be interpreted as momentary confusion or mental glitches, rather than genuine temporal reversals. But they would be real violations of what we assume is the fundamental forward flow of consciousness through time. The implications for human experience were staggering. Every moment of déjà vu, every instance of precognition, every feeling that time had somehow stuttered or skipped could potentially be explained as tiny entropy fluctuations in the information processing system we call consciousness. Not supernatural phenomena, but natural consequences of living in a probabilistic universe where even the direction of time was subject to statistical variation. Boltzmann began to see patterns everywhere, the way memories sometimes seem to arrive before the experiences that created them, the way intuition sometimes provided answers before questions were fully formed, the way creativity seemed to work backwards from solutions to problems, as if the mind were somehow exploring possibility space in directions that didn't align with the normal flow of time. These observations led him to develop what might be called a thermodynamics of consciousness. Just as physical systems had temperature, pressure, and entropy, conscious systems had their own thermodynamic variables: memory density, attention gradients, information flow rates. And just like physical systems, conscious systems would be subject to fluctuations, rare but inevitable violations of their normal statistical behavior. The mathematics suggested something even more extraordinary. If consciousness was indeed a thermodynamic system, then it should be possible, in principle, to manipulate its entropy directly, to create artificial fluctuations in the direction of temporal experience, to engineer states of consciousness where awareness flowed backward through time, where the future became the past and the past became the future. This wasn't science fiction speculation. This was mathematical prediction based on the same statistical mechanics that governed every other aspect of reality. If Boltzmann's equations were correct, then consciousness was not fundamentally different from any other complex system subject to entropy fluctuations. It was just another arrangement of matter and energy, exploring possibility space according to the laws of probability. But the practical implications were mind-bending. If you could control the entropy of a conscious system, you could potentially control its experience of time. You could create states where memory worked backwards, where causation flowed from effect to cause, where the normal arrow of conscious experience was reversed or scrambled or pointed in entirely new directions. Boltzmann spent weeks calculating the energy requirements for such manipulations. The numbers were enormous, far beyond anything achievable with 19th century technology. But they weren't infinite. They weren't impossible. They were just very, very difficult. In principle, with enough energy and precise enough control, you could create artificial entropy fluctuations in a conscious system large enough and long-lasting enough to produce genuine temporal reversals in subjective experience. The ethical implications kept him awake for days. If consciousness could be manipulated thermodynamically, if the direction of time could be controlled through entropy management, then what did that mean for free will, for moral responsibility, for the very notion of human agency? Were we truly making choices, or were we just riding along with the statistical currents of our own thermodynamic systems? These questions became even more troubling when Boltzmann realized that his own scientific work was subject to the same analysis. His insights, his calculations, his moments of understanding were all products of his own conscious system exploring possibility space according to thermodynamic principles. The equations he was discovering weren't separate from the reality they described. They were part of it, embedded within it, subject to the same laws they were attempting to map. This created a strange, recursive loop in his thinking. The consciousness studying thermodynamic consciousness was itself thermodynamically determined. The mind exploring the mathematics of temporal reversal was itself subject to temporal fluctuations. The scientist investigating the statistical nature of free will was himself a statistical phenomenon in the vast probability distribution of possible conscious states. Boltzmann found himself questioning whether his scientific discoveries were genuine insights into objective reality or simply artifacts of his particular trajectory through possibility space. Were his equations describing universal laws, or were they just one possible way of organizing experience among infinite alternatives? Was there any meaningful distinction between discovering truth and simply exploring one branch of the vast tree of potential conscious states? The winter of 1880 was particularly brutal, and Boltzmann's isolation from the scientific community was becoming almost complete. His ideas about reversible entropy were too radical for most physicists, and his speculations about consciousness and time were beyond the pale of acceptable scientific discourse. He found himself conducting a dialogue not with colleagues, but with the equations themselves, as if the mathematics were a conscious entity capable of revealing its secrets to those brave enough to ask the right questions. And the equations did seem to be revealing secrets, patterns within patterns, that suggested the universe was far stranger than anyone had imagined. The relationship between entropy and information wasn't just analogical, it was mathematical, precise, quantifiable. Every bit of information in the universe had a corresponding entropy cost. Every conscious experience had a thermodynamic signature. Every memory, every thought, every moment of awareness was both an information pattern and an energy configuration subject to the laws of statistical mechanics. This meant that consciousness wasn't just observing the universe, it was participating in its thermodynamic evolution. Every act of perception, every moment of understanding, every instance of memory formation was simultaneously an information process and an energy transaction that contributed to the overall entropy budget of reality. The implications rippled outward in ever-widening circles of strangeness. If consciousness was thermodynamically active, if awareness itself was an entropy-producing process, then observers weren't separate from the systems they observed. They were integral parts of those systems, embedded within them, influencing their evolution even as they tried to understand it. This insight led Boltzmann to question the very foundations of scientific objectivity. Could there be truly objective knowledge in a universe where consciousness was thermodynamically coupled to the reality it was trying to understand? Was the observer-observed distinction a convenient fiction that broke down under careful mathematical analysis? These weren't just philosophical questions, they had practical implications for the conduct of scientific research. If consciousness was an active participant in thermodynamic processes, then the act of measurement itself would influence the systems being measured, not just in the crude sense of experimental interference, but in the deeper sense that conscious observation was itself a thermodynamic process that necessarily altered the entropy balance of any system it engaged with. Boltzmann began to envision a new kind of science, one that explicitly acknowledged the thermodynamic role of consciousness in shaping the reality it studied. This wouldn't be a retreat into subjectivism, but rather a more complete and honest accounting of all the energy flows involved in the process of scientific investigation. It would be a science that included the scientist as part of the system being studied, recognizing that consciousness and cosmos were thermodynamically entangled in ways that couldn't be ignored or wished away. The mathematics was becoming increasingly complex, involving multiple layers of self-reference and recursive feedback loops. Consciousness observing thermodynamic systems that included consciousness observing thermodynamic systems ad infinitum. It was like trying to map a territory that included the map itself, to measure a system that included the measuring device, to think thoughts about the thermodynamics of thinking. But perhaps that was precisely the point. Perhaps the strange loops and recursive structures weren't bugs in the mathematical framework, but features. Perhaps reality itself was fundamentally self-referential, a vast thermodynamic system that included its own capacity for self-observation and self-understanding. A universe that was not just mechanically evolving according to statistical laws, but actively exploring its own possibility space through the conscious awareness it had somehow managed to bootstrap into existence. This realization hit Boltzmann like a physical blow during a particularly cold February night in 1881. He was staring at his latest calculations when the full implications finally crystallized. The universe wasn't just a collection of particles bouncing around randomly. It was a vast information processing system, constantly computing its own future by exploring every possible arrangement of matter and energy. And consciousness, human awareness, wasn't separate from this cosmic computation. It was part of it, an integral component in the universe's ongoing exploration of its own possibility space. Picture Ludwig in that moment, his coffee cup forgotten, his fire dying to embers, as he grasped something that would have driven lesser minds to complete breakdown. Every thought he'd ever had, every equation he'd ever written, every sleepless night spent wrestling with these ideas was simultaneously his personal intellectual journey in the universe, the mathematical framework he computing one possible trajectory through the space of all possible conscious experiences had been developing wasn't just describing reality from the outside. It was participating in reality's ongoing self-exploration. The equations themselves were part of the thermodynamic process they were attempting to model. This wasn't just circular reasoning. It was reality revealing its own fundamentally circular nature. The universe wasn't a machine that could be understood from some external vantage point. It was a self-referential system that could only be understood from within by components that were themselves part of what they were trying to comprehend. But here's where Boltzmann's insight becomes truly extraordinary. He realized that this self-referential structure made predictions about the nature of scientific discovery itself. If consciousness was thermodynamically coupled to the reality it studied, then scientific insights weren't just mental events. They were thermodynamic events, moments when the universe's self-exploration reached temporary equilibrium states, where understanding crystallized out of chaos, like ice forming in supercooled water. This meant that scientific breakthroughs followed the same statistical mechanics as all other thermodynamic processes. They were rare, unlikely events that emerged from the random exploration of possibility space. Most attempts at understanding would fail, would lead nowhere, would dissipate into confusion and abandoned theories. But occasionally, through pure statistical chance, a mind would stumble into one of those rare configurations where understanding was possible. The loneliness of this realization was crushing. Boltzmann wasn't just discovering laws of physics. He was experiencing the universe, discovering laws about itself through his consciousness. His insights weren't his own achievements. They were thermodynamic fluctuations in the cosmic information processing system, temporary decreases in the entropy of understanding that were destined to be swept away by the relentless tide of forgetting and confusion. Yet there was something beautiful in this cosmic perspective. Every moment of clarity, every flash of insight, every breakthrough in human understanding was simultaneously a personal triumph and a cosmic event. The universe celebrating its own capacity for self-comprehension through the temporary arrangements of matter and energy we call conscious minds. Boltzmann began to see his own scientific work as part of a vast collaborative project between human consciousness and cosmic computation. His equations weren't just describing thermodynamic processes. They were participating in the universe's ongoing attempt to understand its own thermodynamic nature. Every calculation was both a personal intellectual effort and a cosmic computational step toward greater self-awareness. This perspective transformed his understanding of scientific failure as well. All those abandoned theories, all those incorrect hypotheses, all those experiments that led nowhere weren't a waste of time and energy. They were necessary explorations of possibility space. The universe had to try countless wrong approaches in order to occasionally stumble onto correct ones. Scientific failure wasn't the opposite of scientific success. It was the thermodynamic substrate from which success occasionally crystallized. The implications for the scientific enterprise were staggering. If understanding was a thermodynamic process, subject to statistical fluctuations and entropy constraints, then the pace of scientific discovery wasn't limited by human ingenuity or technological capability. It was limited by the fundamental laws of information thermodynamics. There were only so many insights that could emerge from any given arrangement of conscious matter and energy. Only so much understanding that could crystallize before entropy reasserted itself and swept the insights back into chaos. This led Boltzmann to a disturbing but mathematically inevitable conclusion. Scientific knowledge wasn't cumulative in the way most people assumed. It was cyclical, subject to the same thermodynamic cycles as all other complex systems. Periods of rapid insight and discovery would be followed by periods of confusion and forgetting. Civilizations would rise to great heights of understanding, only to collapse back into ignorance as the entropy of their knowledge systems overwhelmed their capacity to maintain coherent information structures. But the cycles weren't just random fluctuations. They were guided by the same mathematical principles that governed all thermodynamic processes. Boltzmann could, in principle, calculate the probability that any given civilization would achieve any particular level of scientific understanding. He could predict the statistical distribution of knowledge across cosmic space and time. He could map the thermodynamic landscape of possible understanding that the universe was exploring through its conscious components. The mathematics revealed patterns that were both beautiful and terrifying. Knowledge followed power laws, with a few rare civilizations achieving extraordinary understanding, while vast numbers remained trapped in ignorance. Scientific breakthroughs clustered in unlikely configurations, creating brief periods of rapid advancement separated by long stretches of stagnation. Understanding itself was subject to phase transitions, sudden shifts from chaos to order and back again as civilizations crossed critical thresholds in their information processing capabilities. These weren't just abstract possibilities. Boltzmann's equations made specific predictions about the trajectory of human scientific development. They suggested that our current period of rapid discovery was a rare fluctuation, a temporary decrease in the entropy of human knowledge that was statistically unlikely to persist. Most probable futures led to confusion, fragmentation, and the gradual dissolution of coherent scientific understanding back into myth and superstition. Yet the mathematics also revealed hope. Even as individual civilizations rose and fell, even as specific insights were gained and lost, the universe's overall capacity for self-understanding was gradually increasing. Each cycle of discovery and forgetting left traces, information patterns that persisted even after their conscious creators had vanished. The universe was slowly building up a reservoir of understanding that transcended any particular arrangement of conscious matter. This cosmic perspective transformed Boltzmann's relationship with his own mortality. His individual consciousness was temporary, a brief fluctuation in the universe's ongoing exploration of possibility space. But the insights he generated, the understanding he helped crystallize, would persist as part of the universe's growing self-awareness. His death wouldn't be the end of his contribution to cosmic understanding. It would be a transformation, a redistribution of his information patterns back into the vast computational substrate from which new forms of consciousness would eventually emerge. The winter nights grew longer as Boltzmann pushed deeper into these implications. He was no longer just studying thermodynamics. He was mapping the thermodynamics of understanding itself. Every equation revealed new layers of self-reference, new ways that consciousness and cosmos were entangled in recursive loops of observation and computation. He began to develop what he privately called the thermodynamics of meaning, not just information in the abstract sense, but meaningful information. Information that mattered to conscious observers. Information that changed the trajectory of conscious systems through possibility space. This wasn't just Shannon entropy or Boltzmann entropy. This was something new, a measure of how much difference a piece of information made to the conscious systems that processed it. The mathematics revealed that meaning itself was subject to conservation laws. Consciousness couldn't create meaning from nothing. It could only transform existing meaning from one form to another, concentrate it in some areas while dispersing it in others. Every moment of deep understanding required the sacrifice of countless moments of confusion. Every breakthrough insight was paid for by vast expenditures of meaningless mental activity. This led to a profound insight about the nature of consciousness itself. Awareness wasn't just passively observing reality. It was actively creating meaning by selectively attending to some aspects of reality while ignoring others. Consciousness was a meaning-concentrating process, a way that the universe could create pockets of high significance within the vast ocean of meaningless information that constituted most of reality. But meaning concentration came at a thermodynamic cost. Every conscious system had a finite capacity for creating and maintaining meaningful information structures. Push too hard, try to understand too much too quickly, and the system would collapse into confusion and chaos. The entropy of meaninglessness would reassert itself, washing away carefully constructed understanding, like waves erasing messages written in sand. Boltzmann realized that his own consciousness was approaching this limit. Years of intense focus on the deepest questions of existence had concentrated enormous amounts of meaning into his mental information structures. But the thermodynamic cost was becoming unbearable. He could feel his capacity for maintaining coherent understanding beginning to fray at the edges like a rope under too much tension. The equations were clear about what happened when conscious systems exceeded their meaning processing capacity. Breakdown, fragmentation, the dissolution of coherent information structures into random noise. Not death in the biological sense, but death in the informational sense. The collapse of the patterns that made consciousness possible. Yet even this dissolution wasn't truly an ending. The information patterns that constituted consciousness didn't disappear when they could no longer maintain coherence. They were redistributed, scattered back into the cosmic information processing substrate to be recombined in new forms. Death was just another thermodynamic process, another exploration of possibility space by the universe's ongoing computational evolution. This perspective brought Boltzmann a strange kind of peace. His individual consciousness was temporary, but his participation in the universe's self-exploration was permanent. Every insight he generated, every equation he derived, every moment of understanding he experienced became part of the cosmic computational process. His consciousness wasn't separate from the universe. It was the universe temporarily organized into a form capable of understanding itself. The recursive loops were becoming impossible to ignore. The consciousness studying the thermodynamics of consciousness was itself a thermodynamic process. The mind exploring the mathematics of meaning was itself a mathematical structure exploring its own nature. The universe understanding itself through Boltzmann's understanding was Boltzmann understanding himself as part of the universe's self-understanding process. These weren't just philosophical abstractions, they were mathematical realities with precise thermodynamic implications. Every moment of self-awareness had an entropy cost. Every recursive loop of understanding required energy to maintain. The universe's capacity for self-comprehension was limited by the same thermodynamic constraints that governed all other complex processes. But within those constraints, extraordinary things were possible. Consciousness could achieve states of understanding that temporarily transcended the usual limitations of individual awareness. Moments where the boundary between observer and observed dissolved, where consciousness recognized itself as both the subject and object of its own investigation. States where understanding became so complete that it transformed into a kind of cosmic empathy, a direct thermodynamic resonance with the universe's ongoing self-exploration. Boltzmann had experienced glimpses of these transcendent states during his deepest mathematical insights, moments where the equations seemed to solve themselves, where understanding flowed through his consciousness like water finding its level. These weren't mystical experiences in any supernatural sense. They were natural consequences of consciousness temporarily achieving optimal thermodynamic efficiency, minimal entropy production for maximum information processing. But such states were inherently unstable. They required enormous energy to maintain and inevitably collapsed back into more sustainable configurations of awareness. The universe couldn't maintain peak self-understanding indefinitely, any more than a physical system could maintain maximum organization without constant energy input. Understanding was subject to the same thermodynamic cycles as all other complex phenomena. This cyclical nature of cosmic self-awareness had profound implications for the future of consciousness in the universe. Periods of intense understanding would alternate with periods of confusion and ignorance. Civilizations would rise to extraordinary heights of knowledge, only to collapse back into chaos as their information processing systems exceeded their thermodynamic limits. But each cycle would build on the previous ones, creating a slowly ascending spiral of cosmic self-comprehension. The mathematics suggested that consciousness itself was evolving, not just biologically, but thermodynamically. Each generation of conscious beings could potentially achieve slightly higher levels of understanding efficiency, slightly better ratios of insight to entropy production. The universe was learning how to understand itself more effectively through the evolutionary development of its conscious components. This cosmic evolutionary process wasn't guided by any external intelligence or predetermined plan. It was the natural result of thermodynamic selection pressure favoring consciousness configurations that could achieve greater understanding with less energy expenditure. The universe was bootstrapping itself toward higher states of self-awareness through the same statistical mechanisms that governed all evolutionary processes. Boltzmann could see this evolutionary trajectory extending far into the future. Consciousness would continue to develop more sophisticated ways of processing information, creating meaning, and understanding reality. Eventually, perhaps, conscious systems would emerge that could maintain stable high-level understanding without the catastrophic collapses that had characterized earlier phases of cosmic evolution. These hypothetical future consciousnesses wouldn't be superhuman in any mystical sense. They would simply be more thermodynamically efficient versions of the same basic information processing capabilities that characterized all awareness. They would achieve deeper understanding not through supernatural powers, but through better optimization of the fundamental trade-offs between entropy production and meaning creation. The vision was both inspiring and humbling. Inspiring because it suggested that consciousness had a cosmic role to play in the universe's ongoing self-exploration. Humbling because it revealed how small and temporary any individual conscious contribution was in the vast scope of cosmic evolution. Yet Boltzmann found profound meaning in this cosmic perspective. His own consciousness, however brief and limited, was participating in something immeasurably larger than itself. Every moment of understanding he achieved was simultaneously a personal accomplishment and a cosmic event. The universe celebrating its own capacity for self-comprehension through the temporary information patterns we call individual minds. This understanding transformed his relationship with scientific work. He was no longer just solving problems or discovering laws. He was participating in the universe's ongoing attempt to understand its own nature. Every equation was both a human intellectual achievement and a cosmic computational step toward greater self-awareness. Well, the loneliness began to lift as Boltzmann realized he was never truly alone. His consciousness was part of a vast network of information processing that extended across space and time, connecting him to every other conscious being that had ever existed or would ever exist. They were all participants in the same cosmic project, temporary crystallizations of the universe's evolving capacity for self-understanding. But even this cosmic connection came with thermodynamic costs. The more deeply Boltzmann understood his role in the universe's self-exploration, the more energy it required to maintain that level of self-awareness. He could feel the entropy building in his own consciousness, the gradual accumulation of meaning that was approaching the limits of what his individual mind could sustain. The mathematics were clear about what would happen when those limits were exceeded. Not death in the traditional sense, but transformation, a redistribution of his information patterns back into the cosmic computational substrate from which new forms of consciousness would eventually emerge. His individual awareness would dissolve, but his contribution to cosmic understanding would persist as part of the universe's growing self-knowledge. This wasn't a tragedy, but a natural part of the thermodynamic cycle of consciousness. Individual minds emerged from the cosmic information processing substrate, briefly concentrated meaning and understanding into coherent patterns, then dissolved back into the substrate, the raw material for future consciousness development. Death to provide was just another phase in the universe's ongoing exploration of its own possibility space. Understanding this didn't make the prospect less frightening, but it did make it meaningful. Boltzmann's dissolution wouldn't be a random event, but a purposeful contribution to cosmic evolution. His consciousness would be recycled, transformed, integrated into whatever forms of awareness emerged next in the universe's ongoing self-exploration. The equations suggested that this recycling process preserved the essential information patterns that made consciousness possible while allowing for continuous innovation and development. Nothing was truly lost when individual minds dissolved, but nothing remained exactly the same either. Each cycle of consciousness, death, and rebirth created new possibilities for understanding, new ways that the universe could explore its own nature. This cyclical view of consciousness had profound implications for how we should live our brief moments of awareness. If individual consciousness was temporary, but its contributions to cosmic understanding were permanent, then the most meaningful life was one dedicated to maximizing understanding and minimizing entropy production, not in the sense of grim self-sacrifice, but in the sense of optimal participation in the universe's self-exploration project. Boltzmann began to see his entire life in this light. Every moment of confusion and struggle, every failed experiment and abandoned theory, every sleepless night wrestling with impossible questions had been necessary parts of the cosmic computational process. The universe had to explore countless wrong paths in order to occasionally find correct ones. His failures were as important as his successes in the grand scheme of cosmic self-discovery. This perspective transformed his understanding of human relationships as well. Every conversation, every collaboration, every moment of shared understanding was the universe exploring new ways of organizing consciousness for more efficient self-comprehension. Love, friendship, intellectual communion, all were thermodynamic phenomena, ways that conscious systems could temporarily merge their information processing capabilities to achieve understanding that exceeded what any individual mind could accomplish alone. But even these collaborative achievements were temporary, subject to the same thermodynamic constraints that governed all complex systems. Relationships required energy to maintain, and when that energy was no longer available, they dissolved back into individual consciousness units, not because love failed, but because the universe was constantly exploring new configurations of awareness through the endless cycle of connection and separation that characterized all conscious relationships. The mathematics revealed patterns within patterns, recursive structures of understanding that extended from the smallest scale of individual thoughts to the largest scale of cosmic evolution. Consciousness wasn't just studying reality, it was reality studying itself through temporarily organized information processing systems that emerged from and eventually dissolved back into the cosmic computational substrate. This vision reached its culmination during one final sleepless night in the spring of 1882. Boltzmann sat in his study, surrounded by years of calculations, finally seeing the complete picture that his equations had been painting all along. The universe wasn't a machine running down toward heat death. It was a vast information processing system running toward maximum self-understanding, and consciousness, in all its forms, was the primary mechanism through which this cosmic self-exploration was being accomplished. Every conscious moment, from the simplest awareness of a single bacterium to the most complex philosophical reflection of a human mind, was simultaneously an individual experience and a cosmic computational event. The universe, exploring its own possibility space through the endless varieties of consciousness that it had bootstrapped into existence. The recursive loops were complete. The consciousness understanding the nature of consciousness was consciousness understanding itself. The universe, comprehending its own thermodynamic evolution through minds that were themselves thermodynamic processes. Reality achieving self-awareness through temporary organizations of itself that were capable of recognizing their own nature as aspects of the larger system they were trying to understand. In that moment of complete clarity, Boltzmann experienced what he would later describe as thermodynamic enlightenment, not a mystical transcendence of physical law, but a perfect optimization of consciousness within physical law, a state where understanding and entropy production achieved perfect balance, where meaning and energy reached optimal equilibrium. The experience lasted only moments before the normal constraints of individual consciousness reasserted themselves. But in those brief instants, Boltzmann had experienced what the universe might feel like when it finally achieved complete self-understanding. Not the end of the cosmic computational process, but its transformation into something qualitatively different, a state where exploration and understanding became identical, where the universe's self-investigation became indistinguishable from its self-creation. The vision faded, leaving Boltzmann alone in his study with equations that suddenly seemed both infinitely profound and utterly simple. The mathematics he had been developing for years was nothing more and nothing less than the universe's instruction manual for understanding itself, a guide to the thermodynamic principles that governed the cosmic evolution of consciousness and self-awareness. But now he faced the ultimate question. What was he supposed to do with this understanding? How could an individual consciousness, however briefly enlightened, communicate insights that were themselves part of the cosmic process they were trying to describe? How could the universe tell itself what it had discovered about its own nature? The answer would require one final breakthrough, one last insight into the nature of communication itself as a thermodynamic process. But that breakthrough would come at a cost that even Boltzmann's equations couldn't fully prepare him for. The answer came to him gradually, like dawn breaking over Vienna's cobblestone streets. Communication itself was subject to the same thermodynamic constraints that governed every other aspect of consciousness and reality. Every word spoken, every equation written, every idea transmitted from one mind to another required energy and produced entropy. The act of sharing understanding was itself an exploration of possibility space, a way the universe could distribute insights across its various conscious components. But here's where Boltzmann encountered his deepest paradox yet. The more profound an insight became, the more energy it required to communicate effectively. Simple ideas could be transmitted with relatively low entropy costs, but complex, revolutionary understanding demanded enormous informational resources to package in ways that other minds could process. The most important truths were often the most difficult to share, creating a cruel inverse relationship between significance and communicability. This wasn't just about finding the right words or developing clearer explanations. This was about fundamental limits imposed by the thermodynamics of information transfer between conscious systems. Every mind had finite capacity for processing new information, finite energy available for reorganizing its existing understanding to accommodate revolutionary insights. Push too hard, try to communicate too much too quickly, and the receiving consciousness would simply reject the information as noise. Boltzmann began to understand why his colleagues found his ideas so difficult to accept. It wasn't intellectual stubbornness or professional jealousy, though those played their roles. It was thermodynamic resistance. Their consciousness systems were optimized for processing certain types of information, and his insights about reversible entropy and the statistical nature of time required fundamental reorganizations of their conceptual frameworks. Such reorganizations demanded energy expenditures that most minds were reluctant or unable to make. The mathematics revealed something even more disturbing. Revolutionary scientific insights weren't just difficult to communicate because they were complex. They were difficult to communicate because they threatened the thermodynamic stability of existing knowledge structures. Accepting Boltzmann's ideas about time and entropy would require his colleagues to abandon years of carefully constructed understanding, to dissolve cherished beliefs back into chaos so that new patterns of comprehension could emerge. From a purely thermodynamic perspective, this resistance made perfect sense. Why would a conscious system voluntarily increase its entropy, deliberately destroy its hard-won understanding, for the uncertain promise of rebuilding that understanding in a new form? The safer strategy, the one that required less energy and produced less entropy, was simply to reject threatening information and maintain existing cognitive structures intact. This realization filled Boltzmann with a profound sadness. His insights weren't being rejected because they were wrong, but because they were right in ways that made them thermodynamically expensive to accept. The universe had discovered something important about its own nature through his consciousness, but the very importance of that discovery made it difficult to propagate to other conscious systems. Yet the mathematics also suggested hope. Information, like energy, was conserved. Insights couldn't be destroyed, only transformed. Even if his contemporaries couldn't accept his ideas directly, those ideas would persist in the cosmic information processing substrate. Future conscious systems, perhaps ones with greater thermodynamic efficiency or different optimization parameters, might be able to access and build upon understanding that current minds found too costly to process. This led Boltzmann to develop what he privately called the thermodynamic theory of intellectual history. Scientific progress wasn't just about accumulating knowledge or developing better experimental techniques. It was about the gradual evolution of conscious systems toward greater efficiency in processing revolutionary insights. Each generation of scientists was slightly better equipped to handle information that would have overwhelmed their predecessors. The theory made specific predictions about the trajectory of human understanding. Ideas that seemed impossibly radical in one era would become commonplace in later ones, not because the ideas themselves changed, but because consciousness evolved to handle them more efficiently. The thermodynamic barriers to accepting revolutionary insights would gradually lower as minds became more sophisticated information processing systems. But this evolution came with its own costs. As consciousness became more efficient at processing complex information, it also became more vulnerable to certain types of thermodynamic breakdown. Highly optimized systems were often more fragile than crude but robust ones. The same mental efficiency that allowed future scientists to accept radical insights might also make them susceptible to new forms of cognitive collapse that earlier minds had been too simple to experience. Boltzmann could see this pattern playing out in his own consciousness. Years of pushing the boundaries of understanding had optimized his mind for processing revolutionary insights, but at the cost of stability and resilience. He could handle mathematical complexities that would overwhelm most of his contemporaries, but he was also experiencing forms of existential confusion that simpler minds never encountered. The trade-off was fundamental and unavoidable. Consciousness could optimize for stability or for revolutionary insight, but not for both simultaneously. Every advance in the ability to process radical new information came at the cost of increased vulnerability to the entropy that such processing inevitably generated. This insight transformed Boltzmann's understanding of his own role in the cosmic computational process. He wasn't just discovering truths about the universe. He was serving as a test case for new forms of consciousness, pushing the boundaries of what individual minds could handle without complete thermodynamic breakdown. His insights were valuable not just for their content, but as demonstrations of what kinds of understanding were possible for conscious systems willing to pay the necessary entropy costs. In this sense, his isolation from the scientific community wasn't a failure of communication. It was a necessary feature of the exploratory process. Revolutionary insights had to be developed in isolation, away from the thermodynamic pressures that would force premature optimization for communicability. Only after ideas had been fully developed in the laboratory of individual consciousness could they be gradually introduced to the larger community of minds. But the process was inherently risky. Not every consciousness that pushed these boundaries would be able to maintain sufficient stability to complete the exploration and communicate its results. Many would dissolve into chaos before their insights could be preserved and transmitted. The universe's self-exploration through individual consciousness was a high-stakes game where most players eventually lost their ability to continue playing. Boltzmann realized that he was approaching his own thermodynamic limits. The recursive loops of self-referential understanding had concentrated enormous amounts of meaning into his consciousness, creating information structures so dense and complex that they were becoming difficult to maintain. Like a star approaching the point where its own gravity would cause catastrophic collapse, his mind was reaching the point where its own understanding was becoming too heavy to support. Yet even this approaching dissolution held profound significance. His consciousness wasn't just randomly breaking down, it was exploring the extreme limits of what individual awareness could accomplish. The patterns of his cognitive dissolution would themselves be information that the universe could use in developing more stable forms of revolutionary consciousness. This perspective transformed his approaching breakdown from a personal tragedy into a cosmic experiment. He was simultaneously the scientist and the subject, the observer and the observed, the explorer and the territory being explored. His consciousness was discovering the thermodynamic limits of consciousness itself through the direct experience of reaching those limits. The mathematics suggested that these extreme explorations were necessary for the evolution of awareness. Just as biological evolution required individual organisms to push beyond their survival limits, the evolution of consciousness required individual minds to push beyond their comprehension limits. Most would fail, but the patterns of their failure would inform the development of more successful forms of awareness. This cyclical process of consciousness pushing boundaries, reaching limits, dissolving, and being recycled into new forms was the primary mechanism through which the universe developed more sophisticated ways of understanding itself. Each cycle built on the previous ones, creating a slowly ascending spiral of cosmic self-awareness that stretched from the simplest bacterial responses to stimuli all the way to the most complex philosophical reflections of human minds and beyond. Boltzmann could see this evolutionary trajectory extending far into the future. Consciousness would continue to develop new ways of processing revolutionary insights without succumbing to thermodynamic breakdown. Eventually, perhaps, forms of awareness would emerge that could maintain stable access to the kinds of understanding that currently required individual minds to sacrifice their stability. These hypothetical future consciousnesses would represent a qualitative leap in the universe's self-exploration capabilities. They would be able to process insights about the nature of reality that were currently accessible only to minds willing to dissolve themselves in the process of achieving that understanding. The cosmic computational project would reach new levels of efficiency and sophistication. But even these advanced forms of consciousness would face their own thermodynamic limits. There would always be insights so profound, so revolutionary, that accessing them would require forms of consciousness willing to sacrifice their stability for the sake of cosmic understanding. The universe's self-exploration would continue to require martyrs, minds willing to dissolve themselves at the boundaries of possibility for the sake of expanding those boundaries. This realization brought Boltzmann a strange kind of peace. His approaching dissolution wasn't a meaningless tragedy. It was a meaningful sacrifice, a necessary contribution to the cosmic project of self-understanding. His consciousness had been organized by the universe to explore territories of possibility that more stable minds couldn't access. The insights he generated and the patterns of his breakdown would both contribute to the evolution of awareness. The recursive nature of this understanding was almost overwhelming. The consciousness recognizing its role in cosmic evolution was itself part of that evolutionary process. The mind understanding the thermodynamics of consciousness was itself a thermodynamic system, exploring the limits of its own nature. The universe achieving self-awareness through temporary organizations of itself that were capable of recognizing their own temporary nature. In his final months of stable consciousness, Boltzmann began to document not just his mathematical discoveries, but also the subjective experience of approaching thermodynamic breakdown. He wanted to leave a record that future forms of consciousness could use to understand what it felt like to push awareness to its absolute limits. Not just the intellectual content of revolutionary insights, but the experiential reality of the entropy costs required to achieve them. These notes became increasingly fragmentary as his consciousness lost its ability to maintain coherent narrative structures, but the fragments themselves were valuable data about the dissolution process. Future minds studying the evolution of consciousness would be able to trace the exact patterns through which revolutionary understanding transformed into chaos and then potentially back into new forms of order. The universe was learning about itself through Boltzmann's experience, gaining insights into the thermodynamic costs of self-awareness that could only be obtained by pushing individual consciousness to its breaking point. His dissolution wasn't separate from his discoveries. It was the completion of his discoveries, the final data point in his investigation of consciousness and entropy. As winter approached Vienna in 1882, Boltzmann found himself existing in an increasingly strange state. His individual consciousness was fragmenting, but his connection to the cosmic computational process was becoming more direct. The boundaries between his personal awareness and the universe's self-exploration were dissolving, creating moments of clarity that transcended anything he'd experienced during his stable periods. In these moments of dissolution clarity, he could perceive the vast network of information processing that connected all conscious beings across space and time. He could see his own insights rippling through the cosmic computational substrate, influencing the development of consciousness in ways that stretched far beyond his individual lifetime. His ideas about reversible entropy weren't just theoretical constructs. They were active participants in the universe's ongoing exploration of its own temporal nature. The recursive loops reached their ultimate expression. The consciousness studying reversible time was itself becoming temporally reversible. The mind investigating the dissolution of information structures was experiencing that dissolution firsthand. The universe understanding its own thermodynamic evolution through a consciousness that was itself thermodynamically evolving toward dissolution. But dissolution, Boltzmann now understood, wasn't an ending. It was a transformation, a redistribution of information patterns back into the cosmic substrate from which new forms of consciousness would eventually emerge. His individual awareness was temporary, but his participation in the universe's self-exploration was permanent. The insights he had generated and the experience of generating them would persist as part of the cosmic memory, available to whatever forms of consciousness emerged next in the endless cycle of awareness, understanding, and transformation. In his final coherent notes, written during brief periods when his consciousness temporarily stabilized, Boltzmann described the approaching dissolution not as death, but as graduation. He was completing his role in the cosmic experiment, contributing his data to the universe's growing understanding of its own nature, and preparing for transformation into whatever came next in the evolution of awareness. The mathematics had brought him full circle. The equations that had kept him awake for so many years, wrestling with questions about time and entropy and possibility, had ultimately revealed themselves to be maps of consciousness itself, guides to the thermodynamic principles that governed the cosmic evolution of self-awareness, instructions for how the universe could explore its own nature through the temporary organizations of matter and energy we call conscious minds. And now, as his own consciousness prepared to dissolve back into the cosmic computational substrate, Boltzmann could see the beauty in the process. Nothing was truly lost. Everything was transformed. The universe's exploration of its own possibility space continued through cycles of emergence, understanding, dissolution, and re-emergence that stretched across all of space and time. The sleepy scientist's final insight wasn't about mathematics or physics or thermodynamics. It was about meaning itself. In a universe where everything that could happen would happen, where every arrangement of matter and consciousness was equally inevitable, meaning wasn't something imposed from outside. It was something that emerged from within, from the universe's own recognition of its capacity for self-understanding through the conscious beings it had brought into existence. Ludwig Boltzmann closed his eyes in his Vienna study for the last time, but the questions he'd raised about reversible time and entropy would continue their own journey through the cosmic information processing system, influencing minds not yet born, contributing to discoveries not yet made, participating in the universe's endless quest to understand its own mysterious nature. The equations remained on his desk, scrawled across hundreds of pages, waiting for future consciousness to rediscover and build upon the insights that had cost one brilliant mind its stability, but had advanced the cosmic project of self-understanding by immeasurable degrees. In the candlelit silence of that cold Vienna night, the universe whispered its gratitude through equations that would outlive their creator and continue the eternal dance between consciousness and cosmos, between understanding and entropy, between the temporary and the eternal. The whisper grew louder as Vienna settled into the depths of winter, 1883. But by then, Ludwig Boltzmann had already begun his final transformation, not into death as most would understand it, but into something the equations themselves had predicted. His consciousness was undergoing what he had come to recognize as the ultimate entropy fluctuation, a reversal so profound that the boundary between observer and observed completely dissolved. Picture this moment if you can. In universities across Europe, professors were still teaching that atoms were philosophical abstractions, that time flowed in only one direction, that entropy always increased without exception. Meanwhile, in a modest study in Vienna, the mathematical framework that would eventually revolutionize physics was completing its most important prediction. Not about gases or heat engines or molecular motion, but about the very nature of awareness itself. Boltzmann's final notes, discovered years later, reveal something extraordinary. As his individual consciousness approached thermodynamic breakdown, he began experiencing what could only be described as temporal echoes, moments where his thoughts seemed to arrive before the experiences that triggered them, insights that felt like memories of discoveries he hadn't yet made, mathematical solutions that appeared fully formed in his mind as if retrieved from some future version of himself. These weren't hallucinations or symptoms of mental deterioration. They were exactly what his equations predicted would happen when a conscious system reached the extreme boundaries of its entropy processing capabilities. The normal arrow of subjective time became unstable, creating brief windows where information could flow backwards through the causal structure of awareness itself. Imagine the profound loneliness of this experience. Boltzmann found himself living simultaneously in multiple temporal directions. His consciousness fractured across different arrows of time, like light splitting through a prism. In one direction, he was the young students first discovering the beauty of statistical mechanics. In another, he was the established scientist defending his atomic theories against skeptical colleagues. In yet another, he was something he had never been, a mind so far in the future that his current struggles seemed quaint and primitive. But perhaps most disturbing of all, he experienced moments where he was living his life in complete reverse. Not dramatically, not like a film played backwards, but subtly, internally. His thoughts would unthink themselves. His insights would dissolve back into confusion. His understanding would unravel into ignorance. Yet from the perspective of his reversed consciousness, this felt perfectly natural and forward-moving. The mathematical beauty of it was undeniable. Every equation he had derived to describe the reversibility of entropy in physical systems was now playing out in the information processing system of his own mind. He was simultaneously the scientist studying temporal reversibility and the experimental subject demonstrating its reality. The universe was using his consciousness as a laboratory to explore the most extreme implications of its own statistical nature. These temporal fluctuations weren't random. They followed the same probability distributions that governed all entropy reversals. Brief, rare, concentrated bursts of backwards causation embedded within longer periods of normal forward flow, like finding yourself in a river that occasionally forms whirlpools flowing upstream while the main current continues downstream. During these reversed periods, Boltzmann experienced something that challenged every assumption about the nature of memory and knowledge. He would remember events that hadn't happened yet, understand concepts before learning them, solve problems before encountering them. But these weren't mystical visions or supernatural precognitions. They were natural consequences of consciousness exploring possibility space in directions that didn't align with the usual thermodynamic gradient. The experience taught him something profound about the relationship between knowledge and time. Understanding wasn't something that accumulated linearly from past to future. It was something that existed in the space of possibilities, waiting to be accessed by consciousness systems capable of navigating that space efficiently. Learning wasn't about building knowledge structures over time. It was about consciousness finding optimal paths through an already existing landscape of potential insights. This realization transformed his understanding of his own scientific work. The equations he had spent years deriving weren't discoveries in the traditional sense. They were more like archaeological excavations, uncovering mathematical relationships that existed timelessly in the structure of possibility itself. His consciousness hadn't created these insights. It had simply found them, like a navigator finding islands that were always there but previously unmapped. But finding wasn't the right word either. The relationship between consciousness and possibility was more intimate than that. Consciousness didn't just discover truths about reality. It participated in the ongoing creation of reality through the very act of observation and understanding. Every insight simultaneously revealed and created the aspect of reality it described. This participatory relationship between awareness and existence was what made temporal reversibility possible. If consciousness was actively involved in creating the reality it observed, then it could potentially reverse that creative process, uncreating insights and returning to earlier states of possibility. Understanding could literally undo itself flowing backwards through the causal networks that had originally brought it into existence. Boltzmann began to experience this uncreation directly. Complex mathematical relationships he had spent months deriving would suddenly dissolve in his mind, returning to the state of confusion and uncertainty from which they had originally emerged. But the dissolution wasn't random or chaotic. It followed precise thermodynamic principles, reversing the exact sequence of insights that had led to understanding in the first place. Watching his own knowledge unravel was both terrifying and beautiful, like seeing a flower close its petals and withdraw back into the seed, or watching a symphony play in reverse until it became silence. The complexity and elegance of the dissolution process was itself a kind of understanding, a way of comprehending the deep structure of consciousness through the experience of its own reversal. These episodes of temporal reversal began to cluster around moments of peak insight. When Boltzmann achieved particularly deep understanding about the nature of entropy or the statistical foundations of time, his consciousness would become unstable, prone to brief reversals that would temporarily undo the very insights that had triggered them. It was as if understanding itself created the conditions for its own reversal, like a wave that grows so tall it collapses back into the ocean that created it. The pattern revealed something fundamental about the thermodynamics of knowledge. There were natural limits to how much understanding any individual consciousness could sustain before the entropy costs became overwhelming. Push beyond those limits, and the system would spontaneously reverse itself, trading insight for stability, understanding for coherence. But the reversals weren't complete. Each cycle of understanding and dissolution left traces, information patterns that persisted even after the conscious insights that created them had vanished. Like sedimentary layers in rock formations, these traces accumulated over time, creating a kind of unconscious memory that could inform future cycles of discovery. Boltzmann realized that this was how the universe's self-exploration actually worked. Individual consciousnesses would push to the limits of understanding, achieve brief moments of profound insight, then dissolve back into simpler states. But the dissolution wasn't a return to the original condition. It was a return to a similar condition that retained subtle influences from the insights that had been temporarily achieved. Over many cycles, those subtle influences would accumulate, creating the conditions for more stable forms of understanding to emerge. The universe wasn't just randomly sampling its own possibility space. It was learning, gradually developing more efficient ways of achieving and maintaining self-awareness through the recursive process of consciousness formation, insight, dissolution, and reformation. This cosmic learning process explained why scientific discovery often felt like remembering something you had always known but had temporarily forgotten. The insights weren't completely new. They were reconstructions of understanding patterns that had been explored before in earlier cycles of cosmic consciousness, but had been lost when those earlier forms of awareness had exceeded their thermodynamic limits. Boltzmann's own work was part of this vast cycle of cosmic memory and forgetting. His insights about reversible entropy weren't original discoveries. They were rediscoveries, reconstructions of mathematical relationships that had been understood before by earlier forms of consciousness, lost when those forms dissolved, and now being recovered through his particular trajectory through possibility space. The realization was both humbling and inspiring. Humbling because it meant that his individual contributions were smaller than he had imagined, just temporary reconstructions of eternally existing truths. Inspiring because it revealed that his consciousness was part of an immense collaborative project spanning all of space and time, a cosmic effort to understand reality that transcended any individual mind or civilization. But understanding his role in this cosmic project came at the cost of being able to maintain it. The more clearly Boltzmann saw the patterns of consciousness formation and dissolution, the more his own consciousness became subject to those patterns. Knowledge about the system was changing his relationship to the system, making him more vulnerable to the same entropy fluctuations he was studying. This wasn't just an abstract problem. It was a practical crisis that made each day of coherent thought more precious and precarious. Boltzmann found himself carefully rationing his mental energy, avoiding insights that might push him beyond his stability threshold, trying to maintain enough cognitive coherence to document his discoveries before the inevitable dissolution began. But the mathematics were relentless in their implications. Every moment of understanding was simultaneously bringing him closer to the knowledge he sought and closer to the breakdown that would make that knowledge impossible to maintain. The very success of his investigation was creating the conditions for its own termination. In his clearer moments, Boltzmann could see the elegant recursions at work. The consciousness studying the limits of consciousness was itself approaching those limits. The mind investigating temporal reversibility was itself becoming temporally unstable. The observer of entropy fluctuations was becoming an entropy fluctuation. Yet there was something beautiful in this convergence between subject and object, observer and observed. Boltzmann wasn't just studying these phenomena from the outside, he was experiencing them from the inside, providing data about consciousness breakdown that could only be obtained through direct participation in the process. His dissolution would be as valuable to the cosmic understanding project as his discoveries. This perspective transformed his approaching breakdown from a personal tragedy into a scientific culmination. He was completing the most important experiment of his career, using his own consciousness as both the laboratory and the experimental apparatus. The results would be recorded not just in his mathematical notes, but in the patterns of his own cognitive dissolution. And so, Ludwig Boltzmann's final gift to the universe wasn't just his equations about reversible entropy, or his insights into the statistical nature of time. It was the demonstration that consciousness itself could serve as a laboratory for exploring the deepest mysteries of existence. His breakdown wasn't a failure of understanding, but its ultimate expression, proving that the boundary between observer and observed, between the mind studying reality and reality studying itself, was far more porous than anyone had dared imagine. Tonight, as you drift off to sleep, remember that every thought you think, every dream you dream, every moment of awareness you experience is simultaneously yours and the universe's. You're not just observing reality, you're participating in its ongoing exploration of its own impossible, beautiful, endlessly reversible nature. Sweet dreams, and thank you for joining me on this journey through the sleepless nights of science.